Use measurement gauges. In aviation maintenance, precision isn't optional, it's essential. Every component we inspect, every mark we make, must be accurate to the smallest degree. Because in flight, even the smallest errors can escalate into critical failures. Take a simple scribed line. If it's outside the intended cut mark, it might seem like a harmless scratch. But under stress, that tiny flaw can act as a stress riser, a point where cracks begin. Over time, this may cause premature fatigue or even catastrophic failure. That's why AMTs are trained to use precision tools correctly. Two of the most important ones are calipers and micrometers. Let's begin with calipers. Calipers are used to measure the internal and external dimensions of components. During inspection, they help us compare sizes, such as checking part tolerances or matching against a known reference. Calipers come in two main types, outside and inside. Outside calipers are used to measure shafts and rods, anything with an external surface. Inside calipers are designed for bores, slots, and internal gaps. Once positioned, their span is compared against a rule or a calibrated gauge for an accurate reading. Micrometers are the standard for tighter tolerances. The outside micrometer is commonly used to measure thickness, shaft diameters, or small precision parts. It provides accurate readings down to 1/1000th of an inch. Let's look at how a micrometer works. It has a frame, an anvil, a spindle, and a barrel, all controlled by the thimble. As you rotate the thimble, the spindle moves in or out, adjusting the gap where the part is measured. This motion is guided by internal threads, allowing precise, controlled movement for high-accuracy readings. Reading a micrometer takes care and attention. Start with the barrel. It shows the tenths and hundredths of an inch. Then read the thimble scale to add the thousandths. If the micrometer includes a vernier scale, you can read down to 10/1000ths of an inch. Here's an example. The barrel shows 0.275 inches. The thimble adds 0.019. And the vernier scale contributes 0.0004. That gives a final micrometer reading of 0.2944 inches. Let's apply this in a practical inspection. You're checking the diameter of a worn engine shaft. You begin by zeroing the micrometer. Then, you gently position the shaft between the anvil and spindle. You take a precise reading, helping determine if the part is within serviceable limits or needs to be replaced. Best practices for using a micrometer? Always zero it before use. Never over-tighten. It can warp the tool or damage the part. Keep contact surfaces clean. And calibrate regularly using gauge blocks or ring gauges. And finally, never scribe on a finished part unless it's about to be cut. Even a shallow scratch can create a stress riser and weaken the material over time. Remember, choose the right tool, read it correctly, and always handle it with care. Because in aviation, precision isn't just about performance, it's about safety every single time.